Part 2. Solving problems that involve rates. Strategies for solving rate problems. When you're given a rate problem that involves an unknown, the problem can be solved using a variety of strategies. First one, a pair of equivalent ratios. To be equivalent ratios, the units, we can actually take out this part. Whoops. Make sure I'm in pen mode. Okay. The units of the two ratios must be the same. So, for example, if I had the ratio of 3 to 2, let's say that that's cats to dogs. Then a similar ratio, 6 to 4, would also have to be cats to dogs. Okay? We can use a multiplication strategy. We've been doing that a little while now, and especially in our last section. So, problems that require conversions between units. So we have 10 meters in 1 second. That would be 36,000 meters in 3,600 seconds. And then if I said 1 kilometer was 1,000 meters, then I could put my 36,000 meters on the same level, meters with meters, and I know that that would be 36 kilometers. So we just converted 10 meters per second into 36 kilometers per hour. So that's where we can cross-multiply to convert between units. We can also write a linear function, number 3, when a rate of change is constant. So y equals mx plus b. So let's say y is equal to 36x plus 100. Okay, so this would mean we'd start 100 kilometers from, let's learn how to spell, from the origin, and are moving away at 36 kilometers per hour. Okay, good. Example 1. Mario borrowed $500 and paid $850 in simple interest. If he borrowed the money for 18 months, what interest rate was he charged? Okay, so first of all, interest rate is always an annual amount. So therefore, if we have 18 months, we need to convert that into years. So 1 year is 12 months. So if we have 18 months, that's equal to cross multiply. 18 times 1 divided by 12 is 1.5 years. Okay, good. Now, interest is equal to principal times rate times time. We're looking for the interest rate. So how do I get that? How to get rid of times by p? I divide both sides by p. If I'm timesing by t, I have to divide both sides by t. So therefore, my rate is equal to my interest, which was $8.50, divided by my principal, 500, and also divided by my time in years of 1.5. So if you type that into your calculator, you would get 0.0113 blah, blah, blah. All right, so that comes from 850, divide by 500, enter, divide by 1.5, enter. Now, we always express rates in percents. Okay, so therefore, to change that into a percent, we would go 0.0113 out of 1 equals what out of 100%. So again, cross multiply, 100 times that divided by that is equal to 1.13%. And that was the rate at which he borrowed money. Pretty good interest rate if you ask me. All right, last page, on this page, example 2. Describe a situation in which each rate might be used. Identify any factors that could influence the rate in this situation. Okay, so for A, this is as a plane gains altitude, so it goes further up kilometer-wise, closer to space, of course it starts to get colder. So the air, I should say gains altitude, that's kind of helpful. Okay. Altitude, the air temperature, okay, decreases 1.5 degrees Celsius for each kilometer. Okay, Good. So, factors that could influence the rate, probably maybe if there is a storm or the time of year, perhaps, okay? That kind of thing. Again, this is just my example. You can certainly have others compared to mine. Okay, $4.99 per square foot. That's the cost of new flooring for a house is $4.99 for each square foot. Okay, good. Now, what might take into account there that might influence the rate? Could be whether or not you have like pretty straight floors, or if you have to deal with a closet, or you have to go around a bunch of things. Okay, so those are some factors that could influence the rate. All right, good. Page 1 down. Next page, example 3. Melanie wants to defrost a frozen roast which weighs 2.68 kilograms in her microwave. To find out how much time she needs, she looks in a cookbook. She reads that 2 pounds of meat takes 15 minutes to defrost. How long to the nearest minute should she set the timer for? Well, again, our problem is we have things that are in different units. We have kilograms and we have pounds. So we need to convert. Remember that 1 kilogram is equal to 2.2 pounds. Okay, so keep that in mind. Here we go. So we have 2.8 kilograms, so 1 kilogram is equal to 2.2 pounds. So if I have 2.68 kilograms, note top goes with top, kilograms go with kilograms, pounds go with pounds. So we're going to cross multiply. 2.68 times 2.2 divided by 1 is equal to 5.896 pounds. Okay. Now, it also tells us that 2 pounds takes 15 minutes to defrost. So if I have 5.896 pounds, how long is that going to take to defrost? So 5.896 times 15 divided by 2, and again we want to the nearest minute. So when you do that calculation, and again feel free to pause so you can do that calculation, I got 44 minutes. I hope you got the same. Okay, so she should set the timer for 44 minutes. All right, here's an example you can probably try on your own. It's going to use the same skills we just did in the practice. But again, if you want to watch the video and do it with me, then great. Again, if you want to pause the video and try it by yourself and then check your work after, that would be terrific too. Okay, Manpreet has taken a job as a nurse in the Community Health Center in Tuktoyaktuk, Northwest Territories. She plans to ship her car, furniture, and personal effects to Tuktoyaktuk by barge from Vancouver. She's found these shipping rates online. There's light-duty vehicles, so they cost $0.2015 per pound, and furniture and personal effects, which are $0.2734 per pound. Manpreet knows that her car has a mass of 1,250 kilograms. She estimates that she has roughly 550 pounds of furniture and personal effects. Calculate her cost to ship these items to her destination. Okay, so let's start with her vehicle. It's going to cost $0.2015 for 1 pound. And, her car has a mass of 1,250 kilograms. So let's convert that. 1 kilogram is worth 2.2 pounds. So if we have 1,250 kilograms, again cross multiply, so 1,250 times 2.2 divided by 1 gives us 2,750 pounds. So let's bring that back over here. So pounds go with pounds, so they should both be on the bottom. Okay, and again cross multiply, 2,750 times 0.2015 divided by 1. And we get $554.13. Okay, so that's what it's going to cost for her vehicle to get shipped. Now let's talk about her furniture and personal effects. It costs $0.2734 for 1 pound, and she estimates that she has 550 pounds. So again, pounds go with pounds. Cross multiplying 550 times 0.2734 divided by 1 gives us $150.37. Please remember we should always round money to 2 decimal places. Okay, so altogether then, her total would be 554.13. Oops. Getting ahead of myself here. Plus 150.37, and we would get $704.50. And that's what it would cost for Manpreet to take her stuff from Vancouver to Tuktoyaktuk. Okay, last page. Here we have, we went from BC and Tuktoyaktuk to the lovely province of Saskatchewan. All right, the map on the right shows Prince Albert National Park in Saskatchewan. The scale of the map is 1.3 centimeters to 20 kilometers. So what that means is that for every 1.3 centimeters we draw on the picture, represents 20 kilometers in real life. Now, remember that 1 kilometer is the same thing as 1,000 meters. So if I have 20 kilometers, that's going to be times by 20, so times by 20. So that's 20,000 meters. Okay? So for every 1.3 centimeters on the map, that represents 20,000 meters in real life. Why am I changing it to meters? Well, Part A asks us to estimate the area of the park in hectares. 1 hectare is equivalent to 10,000 square meters. Aha! Therefore, we need to make sure that we're working in meters and not kilometers. Okay, so if you were to take out your ruler and roughly measure the length. So if you take out your ruler and measure between here and here, and again, remember we're estimating because the park kind of dilly-doodles over here a little bit, so we're just going to treat it like a rectangle. All right, I measured it to be 9.1 centimeters on my picture, on my printout. You can measure it and do whatever you want, but that's what I got. Okay, so here's the length. Remember that 1.3 centimeters in picture represents 20,000 meters of real life. So I measured the length to be 9.1 centimeters on my picture. So cross multiplying 9.1 times 20,000 divided by 1.3, and I got 140,000 meters. Okay, that's my length. We'll do the same thing for the width. So 1.3 centimeters represents 20,000 meters in real life. And when I measured the width, I measured from here to here. Okay? And I found it to be about 5.35 centimeters. So when I cross multiply 5.35 times 20,000 divided by 1.3, I get 82,308 meters. All right, good times. Now, we're looking for the area because I assumed it was a rectangle. Area is equal to length times width. So my length was 140,000 meters. And my width was 82,308 meters. So when I multiply them together, I got a ridiculous number. 115,230,76923 square meters. Yick. All right, now we need to change that into hectares. So remember up here it says that 1 hectare is equal to 10,000 meters squared. So if you look, this is also in meters squared, so that has to go on the same level on the bottom. 115,230,76923 meters squared. So again, cross multiply times 1 divided by 10,000. So we're going to round it to the nearest hectare. So that worked out to be 115,2308 hectares. That is a lot of hectares. All right, so that's the area of the park. That's a great big park. All right, Part B. The annual cost to monitor and fight forest fires in this region is $48 roughly per hectare. Estimate the annual fire management expenditure for the park. So if it's $48 for 1 hectare, and we have this giant number here, what do we got? 1,152,308 hectares. Then again, we're just going to cross multiply that big number times 48, divide by 1. Again, feel free to turn off the video while you type this onto your calculator. I got 55,310, $769.23 to manage or to firefight for the park. That's significant. 55 million. Wow. All right. Practice. Page 458, questions 1 through 5, 8, 11, 14, and 16. Show your teacher when you got her done.